Uh, hello, good. Uh, Hello, my name is Buzu Aisha. This is my coursework presentation. Question one says discuss the following local search algorithms in relation to artificial intelligence, providing a scenario where each of the algorithms would become handy in solving our daily social problems. One is hill climbing. Hill climbing is a local search algorithm which continuously moves in the direction of increasing elevation to find the highest point or best solution to a problem. Usually it terminates when it reaches a peak value, uh, where it finds no neighbor with a higher value. An advantage of hill climbing is that it is a simple and intuitive algorithm. It's easy to understand and implement. Disadvantage of hill climbing is that it can get stuck in local optima, meaning it may not find a global optimum of the problem. Look at it as basic hill climbing. There are peaks that are not necessarily the peak of the hill. So with hill climbing, once it reaches a peak, that is local optima, and that is the result. It's not necessarily the global optimum, so it never goes beyond that peak. So because of this, it does not explore the search space very thoroughly, which can limit its ability to find better solutions to a problem. A scenario under which hill climbing would become handy is optimization of traffic flow in a city like Kampala. So small changes can be made to the timings of the lights, and evaluating the resulting traffic flow, the algorithm can gradually improve the overall efficiency of traffic flow. The second one is simulated annealing. This simulated annealing is inspired by the annealing process in metallurgy, where a material is heated and then slowly cooled. It's not heated to a melting point, it's heated to a certain point where it doesn't necessarily melt or disintegrate, and then it is slowly cooled. So, this simulated annealing allows the algorithm to um, occasionally accept solutions that are worse than the current solution, which can help it avoid getting stuck in local optima like hill climbing algorithm. A scenario is scheduling of complex events like festivals, conferences. So it can be used to assign speakers to time slots and venues, putting into consideration room capacity, audience preferences in order to find a more global optimal solution. The third is genetic algorithms. These are a class of optimization algorithms inspired by the principles of natural selection. They are useful for solving complex optimization problems where the search space is quite large and intricate. A scenario is designing of optimal routes for delivery vehicles. Genetic algorithms can be used to generate and evaluate different routes, considering factors such as traffic conditions, road conditions, like in Kampala potholes. Yeah. So by modifying and combining these routes, the algorithm can discover new and potentially better solutions. Um, Question 1b says, discuss how you would improve the usability of these algorithms using responsible AI and explainable AI. First of all, explainable AI and responsible AI are concepts using artificial intelligence to make AI models humanly acceptable or interactable, if that's a word. Explainable AI seeks to provide clear and understandable explanations for the operations of artificial intelligence systems. Responsible AI seeks to incorporate AI systems with sensitive human contexts and principles, and to improve the usability of these such algorithms using RAI and XAI, moral principles that are sensitive to human values, like fairness, Is the module fair? Is the system fair to the users? Is it transparent? Does it provide enough information for its use, or for the user that is integrating interacting with it? Is it responsible? Are there repercussions for its operations? Is it accountable? Is there some sort of uh, accountability tree in a way that can hold these systems accountable? Are they adaptable? Can people use them? Can humans interact with them even to the lowest level? Are they autonomous? Can they be explained? What does it do? How does it operate? Why does it react this way, respond this way? So these are very critical to incorporate in order to improve the usability of hill climbing, simulated annealing, and genetic algorithms. Question 2A says define adversarial search. Discuss any two scenarios where adversarial search would become handy in your daily life society. First of all, adversarial search comes from the word adversary, like an opponent. Yeah. So adversarial search is a search algorithm used majorly in game theory, because in games you have a player and an opposing player. Yeah. So it's used in game theory where two opposing players take turns making moves in a competitive environment. Uh, so games like chess, soccer, football in Uganda, tic-tac-toe. It's a Western game. I've not interacted much with it, except through my research in this module. Some of the examples of adversarial research algorithm. Yeah, scenarios under which adversarial research would become handy. One, in negotiations. Negotiations comprise of an opposing party and one that is agreeable to terms. So usually, like in a contract setting, a company wants to offer services at a certain price, and that person or entity is not able to get to come through at that price, so they negotiate. So the environment is competitive, that every single player wants to win, but at the end of it, there is a global solution. Like everyone, both players or whichever number of players who are involved get to a global solution, and they're able to agree. So that's one scenario. Also, another scenario is cybersecurity. Adversarial research can be used to model strategies of cybersecurity attacks, especially during that phase of pen testing, where uh, where attackers that ethical attackers, yes, that's the word, where ethical attack security personnel are able to predict the possible attacks that might come through in a system, and implement countermeasures to counter these attacks. That's also another scenario. Question 2B says, with examples, discuss the minimax and expect minimax algorithms as used in adversarial search. Minimax algorithm is a recursive algorithm which is used in decision making and game theory. It is also used in two-player zero-sum games where one player's gain is another player's loss. Yeah, it works in a way that the algorithm recursively explores a game tree. For example, we studied in data structures, game search trees, like breadth first, depth first. So this algorithm works recursively exploring the game tree and assuming that the opponent will always make the best possible move. So it assigns a utility value to a terminal node. A terminal node is usually the last node that has like the leaf node. So it assigns a utility value based on the outcome of the game. Then it works backwards from the terminal nodes, assigning utility values to internal nodes based on the maximum and minimum values of the child nodes within the tree, all the way to the root node. Yeah, so that's really how it works. An example is in a tic-tac-toe game. The If you know how the game works, the minimax algorithm would assign a utility value of 1 to winning positions. For example, if the winning entity is x, and then the if the max entity is x and then the main entity is an O, if x has a is in the winning position, it will be assigned a value of 1. If it's or, it will be assigned a value of 1, and the losing entity will be assigned a 0, because usually that's the one that has lesser values within the game. And then if it's a draw, they are both assigned, oh, no, as -1 for a losing entity. Yes, that's a -1. And then a 0 for a draw, in case they both come out with the same number of outcomes. Yeah, so next is the expect min-max algorithm. This is a variation of the min-max algorithm. It is used in artificial intelligence systems that play two-player zero-sum games with chance elements. And it works in a way similar to min-max, but it also considers the probability of different outcomes. Min-max does not consider the probability of different outcomes. So when a node presents a chance event, the algorithm calculates the expected utility value based on the probabilities of different outcomes and the utilities of the child nodes within the search tree. Yeah, an example is in poker. The expect min max algorithm considers the probability of drawing different cards and the expected value of different hands to determine the best move. Next is question 2C. With an example, discuss the alpha beta pruning technique. What is its main purpose in adversarial search? Now, the alpha beta pruning technique is a modified version of the min-max algorithm. It's a technique that is used to optimize the min-max algorithm by reducing the number of nodes in the search tree that need to be explored. The algorithm maintains two values for each node, the alpha value and then the beta value. The alpha value represents the maximum or the best value found so far, and then the beta value represents the minimum value from the minimizing player. So if at any point alpha becomes greater than or equal to beta, the subtree search tree in a way that there's a root node, there are child nodes, then there are subroots in there. So in case at any one point value is greater than the beta, the the subtree rooted at the node can be pruned. Yeah. So because the reason why this is done is because it does not contribute to the optimal solution. This is how alpha beta pruning works. So in an example, considering a game tree where the maximizing player is at the root, if at a certain node the alpha value becomes greater than or equal to the beta value of a child node, the subtree rooted at the child node can be pruned because it will not produce any beta value for the maximizing player. Here, the maximizing player is priority. Question 3 says, discuss the concept of adversarial machine learning. Now, adversarial machine learning is a technique that misguides any machine learning model with deceptive data and reduces the accuracy and performance of the model. It is used to execute an attack to corrupt or disrupt a machine learning model by providing deceptive input. A good example of this is a cybersecurity setting. Deceptive data is to reduce its accuracy performance. Yeah. So there are categories of adversarial machine learning attacks. There are two major categories and also subdivided into two other categories. The two major are black box and white box attacks. Black box attacks In black box attacks, attackers about the targeted model and also have no access to its architecture, blueprint, and parameters. White box attackers have access to the targeted model. And then there are targeted attacks and untargeted attacks. In targeted attacks, attackers disrupt the input in such a way that the model predicts a specific target class. Yeah, and then in untargeted attacks, attackers disrupt the input in a way that the model predicts a class, but it should not be a true class. Yeah, so it's deceptive in a way. Then question 3A, still continuing. Adversary machine learning is attacks and reduces their effect on the model. Yes. So a few types of adversary attacks are poisoning attack, where a machine learning model is attacked uh, during its deployment process. Then there is an evasion attack, which is the opposite of the poisoning attack. And usually model extraction attack. It's also known as a black box machine. So it reconstructs the model by extracting data on which it got trained. Yeah. So yeah. Question 3B says discuss how adversarial machine learning is related to adversarial search. Search is a type of search algorithm, as you mentioned earlier in game theory. While adversarial machine learning is, like we mentioned here, the definition, so if so to say. So most importantly, focus of these two. Adversarial machine learning focuses on understanding and mitigating the vulnerabilities of a machine learning model to malicious attack. This can be done usually through ethical hackers, through like an example of how this can be done is through ethical hackers. Yeah. Pen testing is on finding optimal strategies for more players in a competitive environment to find an optimal solution. Yeah. Um, Next is the similarities between these two concepts. So both are rooted in game theory. There are two players, usually an agreeable player or a max player, and then a mean player who is probably on their opposite side. Both of them are on opposing sides, so they are rooted in game theory in a way that they each are working in a competitive environment. um, so both of them have applications in security, like I've been mentioning in my small examples. Examples such as detecting malware, intrusion detection, adversary robustness, um, ethical hacking. Yeah, all these are applications in security. Um, adversary examples as adversarial examples as game theory problems. Uh, Adversarial examples can be viewed as game theoretic problems, where one attacker, maybe a max player, aims to find an input that maximizes the model's error, while another player, a mean player, probably aims to minimize its error. Yeah, so that's also a similarity between the two. This is all. Have a good time.